Good afternoon, everyone. An unseasonably very warm and sunny day in Edinburgh, and we're all stuck inside. Somewhat ironic. I spent the afternoon yesterday in the grass market, sitting in a beer garden, whilst doing my email, I must say, but all the same, just take advantage of that weather. So I'm Kev Dunn. I manage the business for the UK, Ireland, and Nordics for Wasabi. Wasabi are a cloud storage provider. What I want to do today is basically go through how can you avoid pitfalls with moving data to the cloud. There are numerous pitfalls. Some of you will have come across them already. So yeah, I'm going to dive into that, give you a good idea as to planning to avoid them, as opposed to get in there and then find them once you're in the cloud. So firstly, I'm not going to talk about digital transformation today. There's a bunch of other stuff on the agenda. You know, it's a topic that I'm sure a lot of you guys have spent a lot of time with. It's not something I'm going to spend any time with today. You'll be pleased to hear. Secondly, I'm not talking about the financial benefits of moving to the cloud. Again, you know, some of you guys will have seen, you know, moving workloads to the cloud. We're going to save loads of money. This was the nirvana that was pitched 15, 16 years ago. It hasn't come to fruition at all, quite frankly. When you look at it, you know, what is cloud storage? You're moving data from one data center to a data center that somebody else owns, fundamentally. They've got to power, they've got to cool, they've got to manage. So from an economic standpoint, they've got to make profit on what they do. So this whole kind of nirvana of saving money on moving data to the cloud just never really came to fruition. On the flip side, I've seen many customers being stung by moving really high transactional workloads to the cloud and had an enormous bill land on their doorstep. So this is not something I'm going to dive into massively, but we're going to touch upon what those pitfalls are and all that kind of stuff, but yeah, not necessarily about saving money. So I want to try and make this a bit more engaging. So I'm not standing here pitching a product at you. Yeah, this is about how can we go through this in a more interactive fashion. So we're going to tell a bit of a story. Around a hero, the guy that can make something happen, can get a real strong result. So we'll touch on that as we move forward. The thing that got me into IT, I'm just checking I'm on the right slide here. Yeah. The thing that got me into IT many years ago, 1982, my parents bought me one of those, Atari 2600 XL, if anybody can remember that. Some of you guys look roughly my age-ish. Yeah, I broke my joystick in about 2 days, hammering the life out of it. There's a game called Pitfall. Pitfall was all around Harry. Harry was the hero of the game. Harry basically had to run across it. It was this fairly standard, flat, 8-bit graphic platform game where you had to run around avoiding pitfalls. So you had to avoid falling down the hole. So there was a lot of ladder climbing and jumping over stuff and, you know, fairly rudimental stuff. The aim of this was to basically get to the end, collect all the gold, and that was it. I think it was 32 levels, 64 levels, I can't remember. But yeah, Harry was the hero. Like I say, this got me into IT. I remember I had this for about a year, moved on to Sinclair Spectrum, did some basic coding, did all sorts of stuff, and fundamentally, that's why I'm here today. Love this game. So every game's got a goal. Don't know how many computer games I've actually completed over the years. You know, the games where you actually had to just complete the entire thing. You know, you shoot the big alien at the end, or you know, unless you shoot Larry, you walk off with a beautiful lady, or whatever else, right? But these games were fairly basic. You get through your levels, you got to the end, and that's it. You're like, okay, I've got this cartridge, that goes on the shelf. Don't need to play that again. Maybe get your brother to play it or whatever. The name of the game when it comes to moving to cloud, what's the end goal? How are you going to be a hero? If you're pitching this to your business, you're the budget holder, or you're pitching to the budget holder, there's got to be a goal. There's got to be a goal, and what you don't want to do is get 3/4 of the way through the levels, and you get shot by someone, the alien takes you out, you've lost your levels, you've got no shield left, it's kind of game over. And that's what we see a lot of the time. So trying to get ahead of that and being ahead of the game in terms of strategy, going back to the Atari thing, and if you, I might be overusing this analogy completely, but there you go. When you got the Atari 2600 cartridges, there was a little pamphlet in there, little paper pamphlet, and it had the strategy of the game, ultimately how to play the game. I never read it. I just went in 12, 13 years old or whatever I was. That's also happened in cloud storage. Just leaping into it, picking the wrong workload, taking all workloads and just throwing it in there, and you get some point down the line and it comes and bites you on the bum. You get shot by the alien, you get taken out, you lose your lives, you did a little game over. So this is what we want to avoid. So we need to get ahead of this. Examples of cloud pitfalls. You know, you've all seen the press, right? You know, we've all been working in this industry a long while. There's a lot of stuff out there around making sure that when you get there, you're living in the right place, both in terms of application access, network connectivity, performance, cost profile, budget alignment. There's so many different things you've got to think about. It's not straightforward. You know, you could argue it's more complex than managing your own premises environment. Your own premises environment, you kind of, in theory, you should be more in control, right? Because you're not devolving responsibility. So there's a lot of pitfalls to really keep a close eye on. There's landmines all over the place. But yeah, it's a case of getting ahead of that and making sure you understand what you're moving, why you're moving it, and what that goal is. Where's the treasure at the end of the game? Going to the cloud, I've seen multiple customers get to the cloud and put things in the wrong place. Wrong, inappropriate, for whatever reason. Some of the architectures out there, this isn't an AWS or an Azure bashing thing, this is just, it is what it is, right? There's multiple tiers of storage. The reason there's multiple tiers of storage is because there's a cost profile in place. If there wasn't a cost profile in place, you would have one tier. So, you know, a good friend of mine sitting over there, Stuart, we used to work together at EMC many years ago, and we did this whole kind of information lifecycle management piece, if any of you are old enough to remember that, where you'd buy a storage array, you'd move storage from the flash SSD tier down to the fiber channel tier, down to the SAS tier or SATA tier or wherever it happened to be. So you're basically juggling data around. That juggling of data costs money. There's computational cycles, there's the physics of moving it around. It's not straightforward. The application, in theory, needs to be aware of where that data is sitting. If it's not, you could have a highly transactional database hammering a bunch of stuff sitting out on tape. It is a worst case scenario, and obviously you don't want to go there. It'd be much, much easier if you could just do away with all of that stuff, all of that whole tier management piece, because it's literally only there to drive economics. You know, if you've got a data center full of SSD disks, for argument's sake, and that's sitting in the cloud, that's going to cost you X amount. But you're going to get super fast performance, low latency, high transaction rates. If it's down in the super, super dark archive tier, whatever it's called, it's going to be sitting on some tape media. And there might be a 24-hour SLA from when someone hits the button to when that data blocks come back and it eventually gets fed into the application. So it's just that juggling act between where do we put stuff, where does it need to be, does it need to juggle up and down these different tiers, or can we simplify it? And again, it's a big pitfall. It's a strategic planning decision to make sure you know where that data sits and can it move around quick enough to deliver you the cost profile that you need with the performance that's attached to it to make sure your applications aren't sitting there with an egg timer or coming down with an error on a web browser saying unable to access data or 503 errors or whatever. Excuse me. So another pitfall is unexpected charges. They kind of shouldn't be unexpected because they're reasonably well documented now. But if you look into any of the hyperscaler environments, it's not just about storing data equals money. You store the data, you get charged for storing the data, but then you get charged for lots of other stuff. It's kind of like an itemized mobile phone bill. You've got your line rental, then you've got all this other stuff. If you end up going to Egypt on holiday like I did a few weeks ago, you come back with a 270 quid bill, which is a bit scary. Didn't get that one through expenses. But it's complex. Myself and a colleague sat with a customer a few days ago you had 23 petabytes of video storage, post-production house. He basically said, there's my bill. And it was 7 sheets of A4. And he went, I don't know what any of this means. Where do we go from there? So he had no way of reconciling what was actually going on in his environment to the bill that he received. And the bill that he received was about 60% over his budget. So he's like, well, where am I going to go here? So again, it's this understanding of how do you size that? How do you size your budget accordingly to deal with all of this variability? So there's other stuff. There's things like the operational charges, things like API requests. Your applications are going to call into cloud storage asking for X, Y, and Z. Can I have that record? Can I have that block? Each time you do that, it's costing money. It's not free, unless you've negotiated some incredible contract. So again, it's very, very hard to plan that, because with the best will in the world, if it's a customer front end, for instance, you don't know how many API calls it's going to make. It's going to depend on the load that's on that front end, how many customers are hitting you, or if it's an internal system, how hard is that being hit? There's seasonality to look at. There's lots of different factors, so it becomes really, really complex. Where do I put my data? What's it going to cost me? What about all these charges? And it's this whole variable piece where, as IT leaders going to get some budget from the CFO or the CIO or whoever's holding the budget, it's a really, really difficult thing, because you're going to sit there and they're going to say, well, yeah, how much is it going to cost me for the next 12 months? How much is it going to cost me for the next 3 years? And you're going to go, got a good idea, but I'm not sure. In some environments, like for instance, in public sector or higher education, I don't know if there's any of you guys are from that environment, but most of those guys have got fixed term budgets. 3 years, that's what it is. I've got that amount of money. A research department in a large university, I've got 3 years worth of money and I can't get outside of that box. It is what it is. NHS customers, we've got 3 years worth of money. I can't exceed that. I can't have variable costs. So there's been a big reticence in those environments to not move to the cloud because it's too scary. The costs are too high or too unpredictable. So the impact of the API charges alone are considerable. Some fairly simple graphs around 100 terabytes of storage with egress of 10 terabytes. The costs can get quite lively. It's not a difficult bit of mathematics to work out, really. Then when you layer the API stuff on top, it starts to get, again, fairly complicated. You lay the rest of the stuff, GET requests, so you're accessing the data again. So you can see you're building multiple layers of these additional charges, and it's very, very difficult to plan ahead. This slide's meant to look complicated, because it is. Simplifying this stuff is where you'd love to go if you could get there. Just keeps getting more and more complex. So the headline figure of it costs X, Y, Z terabytes per month. You've got to add all this other stuff together to get anywhere near a realistic figure. And again, this is not bashing any of these guys. It's just that's what the business model is. This is all unwelcome surprises. You don't want to get X, Y, Z months down your project and realize that you are heavily under budget, which is quite normal. It's not an unusual thing. But it's something that if you could avoid it, then clearly you'd like to. It's this kind of whole thing about hybrid. You think about I don't know if anyone's ever bought a Toyota Prius. Good cars, well engineered, but it was a bit of a bodge between a petrol car and an all-electric EV. Let's bring something in the middle where, in theory, the petrol engine at some point will recharge the batteries a little bit. You can run off the batteries whilst you're running it, under 30 miles an hour or whatever. But it's a hybrid. You're lugging around heavy batteries and you've got quite a small engine. Well, hang on a minute. How does that stack up? You move to a complete EV, then you might have range anxiety or whatever, but it's a purely designed system that works very, very efficiently. The range that some of the cars are doing now are absolutely phenomenal. You haven't got that hybrid concern that you're compromising yourself. There's no real engineering compromise at all. There's a cost attributed to it, but it is what it is. Just trying to remove that whole compromise. Again, we're kind of reiterating the same point to a certain degree, but yeah, the costs are there. The other thing I think about is lock-in. And again, when I talk to customers, some of the reticence to move workloads from on-premises to cloud is, well, are we going to get locked in? what happens if we fall out with that provider? What happens if there's a technical reason or a commercial reason to move? How do we get out of that? How do we get that data from there over to here or back to on-premises or whatever? And these charging models are very much geared about getting you in there, locking the door, not let you back out again. The graphic of stepping on the landmine in the 8-bit graphics world and being locked in a digital prison is not unusual. The egress costs alone makes it very, very prohibitive to get back out again. This is not scaremongering, it is what it is, we've all seen this, but it gets quite expensive. How do we win the game? How do we get the gold? How do we remove all of these pitfalls? How can we get ahead of it? So from our perspective, we've decided to kind of turn the whole thing upside down. The economics of cloud storage and really change that whole piece in terms of how can you plan, how can you get ahead of it, how can you predict, and how can you make sure that it's potentially less expensive, but certainly no surprises. And that's where we really achieve, that's where we really get a lot of customers coming on board our service in terms of this whole cost predictability piece. Again, game-changing pricing. So the kind of headline pricing for how we deliver a service is kind of up here. But then once you start to look at these different pieces as we roll down, that's where we can achieve the kind of real-life savings that you'll see on the right-hand side. These aren't marketing numbers. These are real numbers that I see on a daily basis in every customer we deal with. Obviously, if you understand, this is just based on egress, by the way. We're not even bothering with API at this point or any of the complicated stuff. These numbers are just basically around a percentage of egress alone. So it gets really interesting in terms of how much you can save, but more importantly, that predictability over time. If you say you're going to store 200 terabytes over a year, and you roughly know what that happens to be, we can give you a little exact price. No matter what you do with it, we can give you that price, and you can move forward, and nothing's going to come and bite you. So the predictability piece is where we're really the whole point of setting this organization up, this company, the service that we deliver, was to kind of disrupt the market very much from a commercial standpoint. You know, the technology is super robust and all that kind of thing, but it's the commercial model that we've gone after, not the technology. The technology's, you know, it's robust. It's a well-published S3 API set. It's not rocket science, right? It's just how can you change the commercial side of things. Come on, clicker, do your stuff. So the pitfalls don't need to add up. This is a real life example from a customer in the USA on a fairly modest amount of storage. If you think about all that kind of stuff racking up in that particular piece, again, we've got Amazon up there. We're not bashing Amazon, it's just an example. But the economics are quite staggering. The difference is fundamental. So that's basically me. I wanted to kind of just get through this. I can do this in about 5 minutes, to be honest. But I wanted to give you the whole idea of why have we done this? What does it do? What's the difference in terms of economics? Which pitfalls can we help anyone avoid? So if you think about that whole planning piece of where do we need to put the data? Which tier does it need to live in? How easily can that data be moved up and down? What are those variable costs? We take away all of that. We have one tier. It's fast, it's commercially viable, and it's cost predictable. And that's me. I'm now in between you and some mini burgers, some wraps. I think there's some salmon. There's a bunch of stuff up there. So any questions, I'll happily take them now. Or obviously we've got a stand upstairs. Yeah, so we can have some questions now, or maybe go grab a burger, come to the stand, and we can have a chat. Excellent. Any questions now? Or? Thank you. So.
What's the secret sauce thing?
What's the secret sauce? So, yeah, the secret sauce in terms of technology, obviously we've designed this using very modern architectures, extremely efficient at how we can deliver high performance in the cloud. So if you think about the kind of economies of that, it gets quite interesting. A lot of the hyperscalers, their architecture is 12 years old in terms of design. Ours is quite modern. But to be honest, the real answer, and That's part of the real answer, but the actual real answer is we don't have to run at a very, very high profit margin to be a very successful organization. Now, I know what the numbers are for our competitors, and they're very large, they're 3 digits. We run on 2 digits sort of margin within a company. So the question is more, how come the pricing model has been so high and so unpredictable and so complex over the years when it really didn't need to be? I don't want to be, again, too disparaging, but you know, that's where we're at. We don't need to run on 3-digit margin. We can run on 2-digit margin fairly easily and be a very successful growing business.
Do you have your own data centers or do you use colos?
So we're co-located. So we've got private suites in Equinix data centers across Europe, Asia Pacific, and North America. So we can offer multiple direct connects into those organizations. So we can use things like Megaport. We've got 10 gig direct connects. We've got smaller customers which will come across public internet. We've just actually launched a Janet interconnect for higher ed, so the joint academic network. So we've got multiple 10 gig connections going into our data centers in London. So we've got a lot of higher ed organizations coming on to us now. So there's no traversing the public internet for those guys. Obviously, it's secure, low latency, etc. A lot of the workloads are things like large data backups, research data, image and video stores, things such as that.
Can you do background replication between regions?
Yeah, sure. Yeah, we can do bucket replication. It's fairly straightforward. So we can replicate between data centers within a region. So we're not doing sort of transatlantic replication yet. The technology's there. We just haven't really invested in the bandwidth at that level, from here to North America, for instance. But certainly within Europe, yeah, it's no-brainer. So again, from a cost model perspective, you're just paying for the storage that you consume. So you're not paying for any transit costs. You're not paying for the replication license or anything such as that. If you store 100 terabytes there, you'll store 100 terabytes there. You get charged for 200 terabytes, and that's it. Again, pretty straightforward stuff. So.
The comparison in cost in terms of, economics, money.
Yeah.
That's obviously appealing. And please do correct me if I'm wrong, I suspect that part of that cost reduction might be coming from using the cheapest available power. Do you know, is there a comparable difference between the carbon output for the service you provide and, say, Google, Amazon, pick your preferred alternative? Basically, I suppose my question boils down to, were an organization to switch to using your services, would they be saving money, but at the cost of potentially having a worse impact on the environment?
It's a really great question. So we've just actually launched a carbon calculator on our website for exactly this question. So obviously, depending on where you are in the world, this seems to be a more important topic. I'm selecting my words correctly there. Certainly in Europe, this is a topic that's the forefront of everyone's mind, and it should be, absolutely should be. We've got the absolute carbon footprint calculated per terabyte for each of our data centers globally. So you can basically select the storage region, work out exactly what that carbon footprint looks like. We're also exposing where that electricity is being generated. Is it from renewable sources? Is it from fossil fuels, etc.? The carbon footprint is slightly different for different regions. Some of the data centers are older, some are younger, some are sourcing their electricity from different places. So yeah, it's something that's forefront of our mind.
And sorry, I will keep you from the burgers for a little time. Just a quick follow-up there because of something you said. The carbon calculator, are the calculations themselves publicly available when you run them?
Yes.
Okay.
Yes, absolutely. Yeah, that was the main point of it. The reason we put it out there on the website was we were having a lot of requests coming in specifically from the UK and mainland Europe predominantly. And it was one of those ones where, okay, if we've got an RFP from a customer in a public environment that's requesting this stuff and it's mandatory, then let's just get it out there. Well, there's nothing to hide, right? Why would you hide it? Let's just get it out there, make it easily accessible, and you can download it from the website. Thank you. Sir?
Do you have storage tiers, or
no,
is it
just one tier.
one level of performance?
Yep, which is fast.
All right, perfect.
Yeah. So,
Can I just ask, in terms of use cases, is it for, you know, let's say you've got a cloud system, it's got photos, video, etc., stored in S3 or something like that.
yeah.
Frequently accessed, you just transfer it over to Wasabi and just change your access to the back end effectively?
Essentially, yes.
Yeah.
Obviously, it needs a bit of planning. But the majority of workloads that we store today are large video stores, large image repositories, backup workloads, so you know, taking a backup copy, long-term retention. Those are the predominant workloads. We work with a lot of sports teams that are producing video that they need a lot of access to or reasonably quick access to do things like post-production. We're doing a lot of work in the health space around medical imaging. You know, the kind of workloads and those workloads have gone to that type of architecture for years, right? The F3 compatible storage, mostly on premises. But that stuff can get quite expensive and difficult to scale, where obviously this is, as far as the customer is concerned, this is infinitely scalable.
In terms of like ingestion events into the storage,
Sure.
is that emitted anywhere? Is that accessible anywhere? Is it possible to get like an S3 file event out of, like, you know, say a newly landed file into a bucket?
Sorry, could you just repeat the beginning of the question?
So, like in AWS or most cloud providers, there would be like S3 file events that you can kind of react to, right?
Yes.
If you needed to be event driven, right?
Yes.
Is there anything in Wasabi Cloud of that sort of standard?
It's a good question. Can we take that question to the guys upstairs? Because I don't want to get out of my depth on that one. I think the answer is yes, but I want to just make sure I can clarify that, if that's okay. Anyone else? No? Well, thanks for your time, guys. I hope you enjoy your lunch and the rest of the afternoon.